Hanze. Today we are going to learn regression analysis, which is the part of the descriptive statistics. And we will first learn what scatter diagrams is. And after that, we will learn how to distinguish dependent and independent variables. And then we will learn what regression analysis is and how to formulate least square estimating equations. And at last of today's course, we will learn how to interpret the coefficient of determination and coefficient of correlation. Now let's come to the first concept, scatter diagrams. First, let's look at this graph. It shows the correlation between age of buses and the maintainer's cost. And from this graph, you may see that the older the buses, the more maintainer's cost you have to spend. So we can also formulate it as the more of your x variable, the more of your y variables. So in this case, we say there is a positive correlation between age of buses and maintainer's cost. In comparison with that, let's look at this one. The correlation between auction price versus odometer. Odometer means how many miles your car has driven. So logically, the more miles your car has driven, the lower auction price you will sell your car in the future. And in this graph, you can say the more of your x variable, the less of your y variable values. So we say there is a negative correlation between odometer and auction price. Now let's look at the third situation. What is the correlation between how tall you are and how much you earn for your salary? And from this graph, you can see that all the data points are randomly scattered. So we will conclude there is no correlation between your height and your salary. For those international students, if you cannot distinguish what dependent and independent variables mean in your own language, we also give the Dutch, German, and Chinese translations there. Please look at the slides. After knowing the scatter diagrams, now let's go on with independent and dependent variables. And we always put independent variables as our x variable. And we call our y variables as our dependent variables. So in the case of the correlation between age of buses and maintainer's cost, the age of our buses will be our independent variables, while the maintainer's cost will be our dependent variables. And let's look at this one. So now it is easy to discern that the odometer is our independent variable and the auction price is our dependent variable. And there is a negative correlation between our independent and dependent variable in this case. And all the regression analysis is based on the correlation between independent and dependent variables. Now let's look at these 5 figures, A, B, C, and D, and E. And you will find in the middle, there is no correlation between our independent and dependent variable. And the difference between figure A and figure B is in figure A, all the data points tend to cluster around the trend line, while in figure B, all the data points are more scattered. So we say that in figure A, there is a strong and positive correlation between x and y variable, independent and dependent variables. While for figure B, there is a moderate and positive correlation between x and y, independent and dependent variables. And you can use the same theory to apply to interpret figure D and E. Figure D, there is a moderate and negative correlation between x and y. Figure E, there is a strong and negative correlation between independent and dependent variables. And all the regression analysis is based on a very simple equation, which is called least square estimation equation. Y hat equals A plus BX. And how to calculate your b? There is a very complicated equation. But don't worry, this equation will be given in the final exam. And based on y hat equals a plus bx, after you know your b, of course, you will automatically know your a. We use y bar minus b times your x bar. Y bar means the mean of your y. X bar means the mean of your x variables. Let's look at this example. Suppose we have 4 trucks, and we document how old our trucks are. And we also document how much repair expenses we have to spend during the last year in hundreds of dollars. For example, the first car, which is 5 years old, we have spent $700 as repair expense. And we first calculate the x bar and y bar. That is the mean of x and y. And the mean of x will be 3, the mean of y will be 6. Step 2. We expand our table. We use x times y for each variable one by one, and then we sum it up. And then we use x variable, we square it one by one, and then sum it up. Then we can go back to this very complicated equation. We replace all the signs with our values, and we get b equals 0.75. And after you know your b, you can come to your a. So your a will be 3.75. Now you know your a intercept and you know your b slope. You can formulate your equation. So your equation will be y hat equals 3.75 plus 0.75 times x. But you may ask, why do we need to use this equation? Now let's look at this example. Suppose we have a truck which is 4 years old, and we want to predict how much repair expense we need to spend on it this year. And now we can make use of this equation. Because the truck is 4 years old, so our x variable will be 4. We use this equation replacing x with 4. And then we get 6.75. So now we can conclude. If we have a truck which is 4 years old, we can predict that we need to spend $675 annually for repairs. So that is why we need to use this regression equation. So the basic concept of regression analysis is that formula. Y hat equals a plus bx, and a is the intercept while b is the slope. After knowing how to calculate your y hat equation, now let's go on to distinguish the coefficient of determination, r squared, and the coefficient of correlation, r, and stand arrows. Suppose all of our data points are scattered on one line. So all the data points are on one line. And then our coefficient of determination, r squared, will be 1. Our coefficient of correlation will be -1, and the standard error is 0. So when we want to interpret that, for coefficient of determination, r squared, we say 100% of y variations are explained by x variations. If we want to interpret r, coefficient of correlation, -1, we will interpret as there is a perfect and negative correlation between x and y variables. These are your independent and dependent variables. Suppose our data points tend to scatter around the trend line. They tend to deviate from the trend line. And how will it influence our r squared and r? Yes, our standard error will increase. And our r squared coefficient of determination will decrease. So in this case, we say the individual values are more scattered from the regression line. So only 24% of y variations are explained by x variations. while the rest 76% of y variations are explained by other variables. And for r equals minus 0.49, we interpret as there is a moderate and negative correlation between x and y variable. So that's today's course, and you will find that actually regression analysis is not that difficult. If you work on it, you will find it can be applied into many fields, like for your consultancy project, for you to predict the GDP of a country, to predict the sales of a company. So regression analysis is very useful. I hope that you will enjoy it. This is our International Business School Descriptive Statistics course, given by Ms. Betty Matter, Xiao Yanxu, and Ning Ding.